Hi, welcome to Del Oro Chemistry. This is Mr. Cornett's class. So here at Del Oro, we're kind of assuming this is your first physical science course. And one of the most important things to be able to do in physical science, and any science, is to make measurements. And so when you make measurements, the first thing we learned in class was if there's some object that you want to measure, and you place a ruler next to it, you line up one end, you look at the other end, and you decide what number to write down. Now, any object, let's say that's a little bar or a box, needs a label. So I would say length of box equals, and I have some number. The number also needs units, which in this case I can tell from the ruler. This side over here is inches, this side over here is centimeters. In our class, we don't usually use inches, not because there's anything wrong with inches, but if you look at this ruler closely, it says there's 1 inch, there's 2 inch, there's 3 inch. And so this line would be a ½ an inch, this line would be a ¼ of an inch, and you can see that the lines are cut up in fractions. In science, we don't use fractional scales, we use decimal scales. So if you look at the centimeter side of this ruler, it says there's 0, there's 1, there's 2, there's 3, and then there's 10 little lines, 10 little spaces in between. So if this is the ones place, then these individual lines down here would be a tenth of the one place, which would be the tenths place, and the spaces in between those, which we would have to imagine, would be the hundredths place. So in this class, we will always use decimal scales, no matter what. Now that doesn't mean it has to be centimeters, it just means it has to be a decimal scale. So what do you do when you want to measure something? Well, first thing you do is you have a complete label like we did in class. You have some sort of mark. This looks like it's about 5. It's not a very clean edge, but it's between the 5.2 and the 5.3. So I'll say it's 5.2 something. I'll guess it's about halfway through and say 5.25. I'll need a unit. And then I need what we're calling the uncertainty, a little marker that says that 5 could be off. If I line up the ruler slightly differently, where I think the end of the bar is could be slightly off. With graduated cylinders, sometimes where your eyeball is can change where that last number looks. So this last digit always has a potential for error. And in fact, in science, for a measurement, you can never know for sure a measurement. You'll never say something, oh, it's exactly that long, because you're always setting it up next to a ruler and making a guess. In this class, we're going to assume that that hundredths place could be off by 1, and we'll put this little plus or minus 1.01 centimeters as the size of our possible error. Okay, so let's look at a couple of examples. Here's a couple of rulers. And let's say there was an object that came to right here, and we wanted to measure the length or wherever that arrow is. Okay, so we would say the arrow is, well, I'll leave the label off just for this example. Is this a decimal ruler? Well, yes, it's going up by ones place. And so if it's going up by ones place, that's past halfway. I would say that's about 2.6. These are centimeters. And I'll give myself a little bit of cushion or uncertainty and say it could be off by 0.1 centimeters. Notice the lines were going up by the ones place, which means if you're going up by the ones place and I have 10 imaginary spaces, those imaginary spaces are worth the tenths place, and that's the place we guess. Look at the second ruler. Let's say something was right here, and I thought, oh, it looks like it's right on the 4. Okay, well, do I say it's exactly 4? Absolutely not, because always when you make a measurement in science, you're kind of guessing where you think that last ruler is. You're assuming that you're lined up correctly here and that you're seeing correctly there. So what do I write? Well, I write 4, but it's less than 4.1. In fact, it looks like it's 4.1 is the smallest line. So these lines in between, if I could see them, they would be worth 0.01. So this ruler has a tenths place, so I will guess the hundredths place, and I will say, well, it's definitely 4 centimeters. It did not make it to the 0.1 centimeter, and I think it's right on the line, at least pretty close, to the hundredths place, and I would say this measurement is about 4.00 centimeters, and I'll put plus or minus the place I guessed. I'm saying that in the hundredths place, at least as near as I can tell, that has 0 hundredths, but I could be off. Someone else might say that's 3.99. Someone else might say that's 4.01. it's really important that these zeros are here. Now in a math class, those zeros wouldn't be written. But in the science class, they're trying to tell you something. They're telling you that you were sure about the ones place. In fact, that's why you learn these things, I think. You were sure about the tenths place, and you guessed the hundredths place. And those zeros mean something. So now I'm going to place another board here, some examples for you to try. Okay, so I'd like you to pause in between each one, and then I'll go over the answer. So looking at this first one, let's say these are centimeters, and let's say there's an arrow right there. So you pause right now. Now, so what did you write for that one? Well, this is going up by the ones place, so that ruler needs to have a tenths place. Looks like it's a little bit past to me, so I would write 3.6 centimeters, and I'll say I could be off by 0.1 centimeters. Okay, let's try this next ruler. Let's assume you were right here on that line, at least pretty close. And you pause and you try it, and I'll go over the answer. Okay, so this ruler, let's see, it has the ones place. It has lines for the tenths place. So this would be like 0.1, 0.2, 0.3, 0.4, all the way up to 1.0. So I know the ones place and the tenths place for sure, which means this ruler must have a value in the hundredths place. If you have the tenths place, every measurement from this ruler has to have a value in the hundredths place. So I would write 2.1, 2, 3, 4, 5. So that's 2.5. And I think it's right on the line, or maybe it's even a little bit less. I'll write 2.49 centimeters. But that 49 could have been a 5.0, depending on how you looked at it. Plus or minus 0.01 centimeters. And that's the correct location of that arrow. Okay, now let's try this next one. Let's say the arrow is right here. These are fat arrows, which makes it difficult to find where you'd actually guess the point. But why don't you pause? Okay, so what did you write? This ruler has a 10, 20, 30, so it has the tens place. If it has the tens place, let's see what else it has. It has the ones place, so that'd be 1, 2, 3, 4. So the tens place and the ones place are known. So if you know the ones place, then you would guess the tenths place. Just like we did up here, we knew the ones place, we guessed the tens place. Here, we knew the ones place, we'll guess the tenths place. So that would be about 9, I think, and maybe a 0.2. And what are these? Centimeters. Oh, I did the one above wrong. Those were inches. Oops. See how important it is to look at units. These were 9.2 centimeters, and I'm guessing that 0.2, so I'll say plus or minus 0.1 centimeters. That means this 2 could be off by 1. Let's say this last one has a ruler, an arrow right there. Why don't you pause? Okay, so now this ruler has the hundreds place, and if you have the hundreds place, these imaginary lines would be worth 10 each. There would be a 10, 20, 30, 40, up to 100. Then it would be 310, 320, 330. So if you can guess the tens place, your measurement must have a tens place. So I would say that looks like it's right on the 400, but that's the place I guessed, not the ones place. So I would say, let's see, these are miles. Boy, that's a strange ruler, but that'd be plus or minus 10 miles. Wow, that's not a very accurate ruler, a very precise ruler, because that measurement, any measurement with this ruler, could be off by 10 miles and you wouldn't even notice. That 10 miles means that's the last place that was measured. This 0, we'll learn tomorrow, is just called a decimal placeholder.